I did want to ask, and TJ, we could start with you. When building this automation framework, what are some things to be cautious of or mistakes to avoid? Are there any mistakes that you've made along this journey that you could point to, like, that's where we went wrong there?
Well, knowing a lot of people in the business that deal with this daily, and also just the whole concept of tech transfer, we heard Matt mentioned it briefly. It's just the protocols, right? My friends on the automation side would always be like, all right, let's make sure it's not, it's a lot of times it's not even a protocol, and it goes over like, all right, it's got to be an SOP, and if there's any ambiguity, we can't automate it. Eating a meal recently, we were discussing one of these things where there was a protocol and it said put it in a glass bead bath. And then as the person automating it went to one person, they put the tubes into the beads. One person put it into a water dish there. And so they realized they were trying to automate something where they weren't even agreeing on what the protocol was before. And so I thought, all right, that sounds like a great example. Not everything is that big or egregious, but these little steps that are done differently by different people are going to be locked into an automated procedure. And so you really have to make sure that one person does it, another person repeats it, gets the same result, and that you really have captured a standard operating protocol before you move it into the automation step. And then I think earlier there was kind of this mention where you don't want to kind of like do it half. You want to try and really make sure you've got something. And then I think that's the part where we talked about you identify the needs and then you can move in. So I think that one is certainly a clear example of making sure you have the protocol to move forward. The second one, before I transfer it to Matt, is also this importance of making sure you've got kind of things are designed, everything's of suitable quality in assay design, and you've got QC steps in place so that you can continue to monitor this step and confirm it and move forward. Because this is certainly a critical aspect to make sure that you're have a robust procedure. So locking down the protocol and having these steps in place, I think are two of the lessons.
Thank you, TJ. Matt?
Yeah, so, I guess I'll start off with kind of reiterating one of the pieces that TJ mentioned is like, robots don't tend to fix bad science, right? So like starting off with, not only lockdown, but like a fully validated. I could probably count on one hand that, the amount of times that a robot actually made a chemistry work that wasn't working in somebody's hands. Sure, it'll make things more reproducible, maybe make things a little bit more tighter, be able to do it a lot faster. But, if you put maybe science that isn't ready for high throughput fashion, you're just gonna have a lot of high throughput bad data. So that's really one of the biggest things, like TJ mentioned, is making sure that works. And also, I think one of the funny things is all the stuff that we take for granted. So, TJ mentioned the ice bath or the bead bath. All the stuff that you do by hand that maybe you don't necessarily capture in an SOP. Like there might be a step where, you unintentionally hold the tube at a 45-degree angle and aspirate off to the side. And it's like, that might not be something that's captured. So it's hard for a robot to do that. So there's a lot of those things that like sometimes when you just really can't make your ends meet, and then you go and watch the researcher do it by hand, you're like, oh, wow, like that's the magic step that, sometimes is hard to kind of capture or anticipate. In terms of, mistakes, I would say, any hardware or software related field, certainly has its best practices. I'd be lying if I said that, we didn't have a few USBs floating around with like some software backups and data on there that, probably isn't backed up the best way. But I think the biggest learning that I've had from automation so far is finding a good balance between getting technologies in-house that we can rely on, stuff that keeps like the lights on, generating data, keeps leadership happy, building momentum and taking everything in the right direction, and also taking the right amount of risks. So, looking at your margins for error, I talked before about your team's capabilities, like your spread to be able to cover if things go wrong, not that anything ever goes wrong in robotics or automation. And then also like being able to evaluate the impact to science, if it does go that route, I think is critical. If you spend your entire budget on an automation framework that has never been deployed before, it's going to be really exciting. And, it's kind of a not so secret thing that every engineer looks forward to is doing something for the first time. But you're certainly creating some risk. And so, I would say finding the right balance between like your excitement for the new stuff, which sometimes my team has to do for me, And then also having like a strong foundation to be able to kind of fall back on or to rely on to, like I said, keep everything moving in the space are kind of two big learnings that I've kind of somewhat used as guiding principles after learning the hard way.
Yeah.
Now that you mentioned risk, I can add one more, right? When we think about a fully automated pipeline, you think, all right, are there steps in this process that we might need to add some redundancy? What is the machine that might fail? How long does it take to get that replaced or repaired? Do we need to own, do we have a second capping step, machine in case the first one breaks and we can't get one replaced? And so I think in some ways it's useful and it's a critical process to think about how each step could be replaced or done by hand. If someone just has to transfer something from step 2 to 3 or do step 3 on a separate machine, but it still enables the whole process to go, then you can think about it one way. But if everything goes down with that one machine and you've heard from other users that they don't really have agents that can get out in any kind of timely fashion, then you might have to rethink relying solely on this pipeline. So there are some kind of war stories that I have heard from this type of process. And one machine that we bought at a past life that just really became a doorstop because it wasn't really fully in place. And so so I think that we could also probably touch on a whole aspect of how to make sure that you're getting what you pay for, but that might be a downstream question.
Yeah, and just even, I guess, one more thing to contribute to that, because the redundancy is a huge thing. And, it's kind of a funny point where we bought an Echo acoustic dispenser fairly early on in Beam. We didn't necessarily have a use for it. Don't tell our leadership. But, we slowly started to adapt it into, damn near every protocol that we started using. And it wasn't until a year or two later where all these protocols not only came online, but they jumped up to be, critical and at really high capacity and high throughput. Running every day, that we kind of turned around and are like, oh wow, we only have one of these. Like all of these assays and all of these pipelines now are essentially relying on this one device. And to TJ's point, it was a single point of failure that would have brought down 80% of my assays. So we very quickly use that as justification and that kind of thing. So yeah, it's a great problem to have when something is critical, but also one of those terrifying moments where you're like, if this goes down and there's not a technician around, like we're in trouble.
So when you were using the Echo, is that one of those examples where you were able to miniaturize the experiments that had a number of improvements that paid off fairly quickly?
Oh, tremendously. So, there's something even as simple as like some of the plasmid we get synthesized elsewhere, you pay extra for a normalization step, right? With the Echo, you can actually dispense the exact nanogram amount you need for a dosing for a transfection, for example. So, you save these costly extra procedures. You're able to scale down. I think it dispenses down to 2 or 7 nanoliters, which I don't know if, how many of our folks have ever seen a pipette go down to 2 nanoliters. But, doing a 10x dilution of your materials of expensive master mixes, to your point, TJ, really quickly pays for the device itself. And you can extrapolate it out to 1 year, 5 year, 10 years. I think that was one of those things that even within 1 year, it actually paid for itself. So then you can, use that to generate more interest and, keep pushing the needle on that.
Yeah, especially if you calculate your tip costs, you realize, how savings come up.
100%. Yep.